Okay, here is the first part of the lesson that will illustrate how to evaluate integrals by trigonometric transformation. At the end of this lesson, you must be able to evaluate integrals involving product of sine and cosine functions. Okay, consider having an integral involving product of sine and cosine function, which can be of the following forms. The integral of sine u, cosine of v dx, or the integral of cosine u, cosine v dx, or the integral of sine u, sine v dx. Okay, where u and v are said to be differentiable functions of x and that u is not equal to v. So this is just telling us that the integral involves product of sine and cosine function of two different angles. Now, the above integrals can be evaluated with the aid of the following trigonometric formulas. If you recall, these are the product to sum identities. So we have 2 times sine u cosine v is equal to the sum of sine u plus v plus sine of u minus v. And that 2 cosine u cosine v is equal to cosine of the sum u plus v plus cosine of the difference u minus v. And for the product 2 sine u sine v, we have it equal to cosine of the difference u minus v minus cosine of the sum u plus v. Now, these identities would help us later in transforming integrals involving product of sine and cosine of two different angles. Okay, let us have some examples illustrating how we can transform an integral that involves product of cosine and sine of two different angles using the identities that we have given earlier. In this case, we evaluate the integral of cosine 5x times cosine of 3x dx. Recognize that what we have here in the integral is the product of cosine of u, cosine of v. And if you recall, twice or 2 times cosine of u times cosine of v is equal to cosine of u plus v plus cosine of u minus v. Picking on u as 5x and v equal to 3x, then applying the identity, the product cosine 5x times cosine 3x will just be equal to 1/2 of the sum cosine of 5x plus 3x and cosine of 5x minus 3x. Simplifying this to 1/2 of the sum cosine 8x plus cosine of 2x. So this integral of cosine 5x, cosine 3x dx can now be written equal to 1/2 the integral of the sum cosine 8x plus cosine 2x times dx. Or we can look at this as a sum of integrals as given by 1/2 the integral of cosine 8x dx plus 1/2 the integral of cosine 2x dx. Recall that we can fit these integrals to form cosine u du, of which the integral is just a sine u plus c. But in this case, our u is 8x. Hence, it would require a differential of 8 dx. Now, we introduce that constant factor 8. Make sure that you multiply the whole integral by its reciprocal. That's why we have there the factor 1, 8. Now, as to the other integral, for the differential of 2x, we need 2 dx. So again, we introduce the factor 2 and then we multiply the whole integral with its reciprocal 1/2. So in this given form, cosine of 8x 8 dx and cosine of 2x 2 dx can now be fitted to the form cosine u du, giving us an integral of sine u. Okay, so we now have this integral equal to 1/2 times 1/8 of sine 8x plus 1/2 times 1/2 of sine 2x plus c, or we have 1/16 times sine of 8x plus 1/4 sine of 2x plus c. For our second example, let us evaluate the integral of sine 4x times cosine 3x dx. In this integral, we now have the product of sine u cosine of v, picking on u 4x and v 3x. And again, if you will look back at the list of identities that we have given earlier, then 2 times sine of u cosine of v would equal the sum of sine of u plus v plus sine of u minus v. So applying that now for this particular product, sine of 4x cosine of 3x would equal 1/2 of sine of 4x plus 3x plus sine of 4x minus 3x, or we just have 1/2 of sine 7x plus sine x. Okay, so now we evaluate the integral of sine 4x cosine 3x dx in terms of 1/2 the integral of sine 7x plus sine x dx, or we have 1/2 of the integral of sine 7x dx plus 1/2 the integral of sine x dx. Again, for sine of 7x, picking on u to be 7x, then du must be 7 dx. So if we will be completing the form of the required du, which is 7 dx, we introduce that factor 7, but we need to multiply the whole integral with 1/7. And in this case, we now evaluate 1/2 times 1/7 integral of sine 7x, 7 dx, plus 1/2 the integral of sine x dx, resulting to the negative of 1/2 times 1/7 cosine of 7x minus 1/2 cosine of x plus c. Recalling that the integral of cosine u du is negative sine u plus c. Okay, so finally, we write the integral equal to 1/14 cosine of 7x minus 1/2 cosine of x plus c. Okay, to recap the discussion that we just had, integrals involving trigonometric functions but would not fit any of the 6 integrals of trigonometric functions can be evaluated by first transforming the said integral using trigonometric identities, and that the integrals that involves product of sine and cosine functions are transformed using the product to sum identities.